I'm gonna go shoot a video. I'll be back. Love you. Gentlemen, let's start from here. Turn some lights on here. So I've left this keyed now for a couple hours. I saw a video of mine. I was in California this last weekend, and I spent, it's been a few days of travel. And I saw this video. I took my PS5 with me. Are you going to focus, camera, or are you just going to think about doing it? I took my PS5 with me, and I was really proud of myself. I figured out how to hack was the focus not working today? Figured out how to hack the hotel Wi-Fi to where my PlayStation was happy, and I was sitting there scrolling through my YouTube on my PlayStation, and it threw this video up. I did the same video 7 years ago now. So what we've got here is a rubber banded down mic, like we threw it in the cup holder of our truck. We've got the OG experiment box number 13. I ran this for several years in my black Tahoe that I had. These are exact same watt meters that were used 7 years ago. The only difference is I don't have my friend Fred Tealton here with me. Fred was, he was honestly, he's the reason that we're here. He's one of the reasons that we're here. We're all here, you and me and everybody else. And boy, how my knowledge has grown. How my fan base has grown, how the channel has grown in the last 7 years. I've had a lot of very influential people come into my life. A lot of really good, smart teachers. But it's been interesting surrounding this whole phenomenon of LD Moss to watch what has happened. I thought this was the cat's meow. And when I first started exploring this technology, because I was not the first one to this table, I was not. We'll move up here. I'm going to show you something here real quick so that you guys can see nothing else is feeding this amplifier. This is running off 12 volts, right? Here's our coax. It's going over here to our bird meters. As you guys can see, we've got about a 400 watt carrier going. 400 watts in reflect, 400 watts in forward. It's just amazing to me how much stuff has changed, and yet how much stuff has stayed the same in the last 7 years. I was really hit with that because I started watching the video. I'm like, oh man, I remember shooting this video. And then I went and watched it, and here's my friend Fred in the background. Missouri boy, he just talked really weird. Good guy though. Heart of frickin' gold. I miss Fred. Fred passed away from a tragic trucking accident. He ended up had a load shift on him, some stuff fall off the load and hit him in the head, ended up killing him. But I first started exploring this. Let's step back in time 7 years ago. 7 years ago, we didn't have the HG 2879 16D08 or the 2879C. The C was still on the drawing table, and I think 7 years ago is when I was doing the original transistor R&D design for North at the time. Also, what was going on at the time is the Meanwell 50 volt switchers, which were the only things that were available to us that were not a computer power supply pole, were relatively cheap. So when we looked at, this is a 1500 watt box, 1200 watt box, depending on how you drive it. And at the time, all we had was Toshiba transistors. This was a cheaper option dollar per watt. Well, then the power supplies got more expensive, the parts got more expensive, everything got more expensive, and then we developed the HG transistor, which we could get at a cheaper price point than the Toshibas by far, and had relatively decent response from those components. That's dead short. Just sitting here shorting a coax out. It's been interesting to me to see what has happened with the radio world since then, because I thought that this was going to be the cat's meow. Let's unkey this for a second and cycle it. Go back to full power again. I thought this was going to be the cat's meow. This right here. It was indestructible for the most part. As far as the coax from the amplifier to the antenna, it didn't care what you had hooked up to it. Its major flaw is that the part is so sensitive that our 100-watt radios, we have to end up putting like 90 watts worth of the power that we get from most of our radios today. We have to run that off in heat and resistors, and it's not the greatest thing in the world, but it's possible, it's doable. But this got to be a little bit too expensive. But this is the future, and I say this 7 years later, knowing that the gentleman that I learned how to build from, Prime Minister, the original OG, the GOAT, despite what the Dave Made camp will tell you, Dave did not do literally diffused MOSFETs first. It was Prime. He was the first one to really explore this, and I don't care. I've been waiting now for a decade for them to show up and give me something other than the one commercial broadcast transmitter picture that they have found that's got some red boards in it, but it's obviously not set up for 11 meters. We're not saying that they haven't come up with something that has worked like this, but they were not the first by far, and they weren't. I would take a Polaroid or a VHS cassette tape with proof on it, or any other form of digital proof other than, well, we say so. Then I might believe. But right now, as we stand here today, no, doesn't hold any water to me. I've had an open call for this evidence now going on a decade. Prime did it first. Prime had the pallets. Prime showed me a working one of these 10 years ago. Actually showed me a working one of these 12 years ago. I didn't understand what I was looking at then, and I'm just now barely able to grasp it, right? I mean, let's be humble about the situation here. I've got attenuators set up on the input of this thing. I designed it to run with the Stryker 955 because it is possible. It is possible. But it just makes me think. I have seen the radio landscape change so dramatically in my time that I've gotten to be involved. There's been a lot of new builders show up. A lot of new builders go by the wayside. There's nothing groundbreaking that's going on here. The only thing that I can say that I might have contributed to the situation is I figured out how to make it work mobile without 48 volt batteries or without a 48 volt alternator. I figured out from my time working in the stereo industry the thing called buck boost, okay, or step up, or DC to DC power supplies. What this has is it's got 3 DC to DC converters on the inside of it. It's the same thing that Sharky came up with, but he found some smaller ones that then he had to go modify, and it was a lot of work. But these were directly from Chinesium Shmoo, and they work great. And take the 12 volt in, chop it up, turn it into an AC signal, boost it back up to 50 volts, and then convert it back into DC, and then we've got our 50 volt supply. So the fan, the relay, all those components are 12 volt. It was very straightforward. When I came across the buck boost that produced enough wattage to drive the amplifier that's on the inside of this thing, I was like, sweet, I've cracked the code. Well, I built a couple of these, and I built about 24 of the LDMOS base units, about half of which the owners blew up. It's because they didn't understand drive. I literally had one customer say to me, he goes, well, it produces the same amount of power, and this is a 2 transistor device, by the way. It produces the same amount of power as an 8 pill. It should take the same amount of drive, don't you think? And I said, no, I don't think. I can't agree with that statement. And he was driving it with a Texas Star 250. Each one of these devices takes 5 watts worth of power to drive it to its full saturation. 5. Not 15, not swing power, 5. That's the Achilles heel of these parts, is too much drive. It'll blow the parts up every time, guaranteed. As you guys can obviously see, it doesn't give a shit what the output ratio is. Right now we're presenting to it probably a 95 to 98 to 1. It's almost 100% dead. Well, that led me down another path. I have been hearing for years and years and years that SWR is what kills the finals in your amplifier. Well, we got to get that SWR down, otherwise that reflect power will feed back and it'll blow up at the finals in your radio. Stupid striker. Or it'll feed back and it'll blow your amp up. No, that's not how this works, obviously. Otherwise, these would have been fried. I'm at almost half of its rated power. Now, please note, this is reflect. This is measuring how much energy is coming back to the circuit. That is forward, measuring how much energy is trying to go out to an antenna or to feed to the circuit. We are absolutely putting out as much as we're getting back. High SWR is not what kills your finals. It's the radical change of impedance. And the heating and the inability for the component to be able to strip the heat away is what kills your component. You have layers of insulation that insulate on the inside of the transistor, and that heat is what breaks down the insulation value inside the transistor and causes it to fail. The part doesn't necessarily care. Is it the best for the part to get it hot? No. There's a giant piece of copper in here that the component is soldered to, and then that soldered piece of copper is now in turn bolted to a piece of heatsink. That's how this magic works. The aluminum's really great at conducting heat to the atmosphere, and the copper's really good at absorbing it and spreading it out over a large area so we can utilize the entire heatsink. There's nothing magical going on here. Like I said, this is old technology at this point. Now we have 2,500 watt, 65 volt components. Now we could do the same thing. Build a DC to DC buck boost converter, put it in a 16 pill size enclosure. Please note how much current we're pulling. 18, 19 amps. We have a much more efficient part because the voltage is higher, but then in turn we're using 12 volt and we're having to switch or upscale that, or switch it up, or transmodulate it, or whatever words you want to use. We're taking 12 volts and we're stepping it up to 50 volts through the buck boost converter power supplies that are in this, the buck supplies. So they're about 80-85% efficient. The transistor itself is in the area of about 70 to 85% efficient itself, right? Which is still much better, and that's because of the higher voltage, by the way, we get that increased efficiency, than the 12 volt parts. I've just seen the landscape of radio change for the better. When I first put all this together, I was in a lockstep fire run to prove to the world that I knew anything about anything. Well, that time has changed, obviously. What happens now is I just get to sit over here and work and play. But at the time, when I first initially shot this video with this amplifier, here we are 7 years later. It's been sitting in the closet for probably 5 years. I had to blow the dust off of it and the dust bunnies and everything else because it's been sitting in the back of the closet. Totally forgot about it until this last weekend. At the time, there was a war that was going on, and it was between builders. My builder's got this technology. My radio guy can do this. My radio guy can do that. La 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 la. Suck a fat one. It's all bullshit. The only thing that we can do as builders to give us a superior edge over the guy down the street at this point is help design the circuit a little bit more efficient to the part. So we're talking a 2 to 3% variance between builders in the quality. 90% of us, all of our parts, except for, well, some rare outlying exceptions like Tech 9 and a few others. You know, those guys, they hand make their cabinets and their boards, and most of the guys, they buy their parts from ICA manufacturing. So therefore, we're all kind of in the same sphere, right? I make my own transformers, but I use their boards and their cabinets. I love my friend Tony. He's a good man. He's a good businessman, and he's worked really hard to become what he has become in the radio industry today. Just everybody was at war. And everybody felt like they needed to run out and tell everybody why they were better than the next guy. And I've seen all of that melt away in the last 6 years. And I'm proud to say I had a little bit of a hand in that. Here I sit now, being able to work on the projects I get to work on now, and I got here by not saying anything negative about anybody and just doing the work. Now, in the same breath, let's circle back one more time. My friend Fred is dead. My friend Frank, Mr. Black, he's gone. I look around and I see probably half of my friends that I had 7 years ago are now gone. Yes, they've been replaced by new people, but still, they're gone. I have felt a pressing need now going on for the last 4 years to try and get oral history from people. The people here at Patreon have helped me be able to set that goal free. And I've got a trip coming up towards the end of this month where I'll be away from the shop for 30 days. In that amount of time, I'm going to get as many people to sit down with me on interview as I can possibly get. I want to preserve that history, because once these people lose their voice by passing away, they're gone. We don't get to hear from them ever again. So I hope you guys understand. The YouTube channel is going to slow down a little bit for the next couple weeks. I'm going to do a bunch of stuff here behind the scenes for the next 2 weeks. I'm going to be doing repairs left, right, and center. So the videos are going to keep coming out at the regular pace that you guys are used to. I'm not going to be here. I'm going to be off working on other stuff. Preserving radio history. Another video that I saw while I was in California, it suggested that I watch, was an actual walkthrough tour of Ameritron. Now, you guys know I don't have any love for MFJ, but I want to help preserve that history. So I'm going to reach out to them and see what they have to say about things. I would love to go take a tour of the Ameritron plant and talk with those guys down there, if they're still making the stuff here in the United States, which I hope that they are. This is a 16-year-old video, believe it or not, that I watched, and you can tell it was totally shot on the like a handheld tape reel camcorder, right? So maybe we can give them a little bit more modern uptake, but we're going to try and get that worked in too. We'll see. We'll see. SWR is not what you think it is. There's a beautiful book that was written by William I. Orr. You can go find the PDF on it. He wrote the Antenna Handbook. William Orr was never an engineer. And I love how people, they always prop up. Like, I start talking about William Orr or Bill Orr, they hop up, well, he was never an engineer, so therefore he wasn't. And I look at these people and I go, oh, look, the ugliness coming out of you is painful right now. What Bill Orr, in my mind, is God. Why is Bill Orr God? It's not that he was an engineer, because he wasn't. He had this God-given gift where he could sit down with engineers and take something that used a lot of big words and was very complex to help visualize it in the head, translate it to something that was easy to visualize, and used smaller words with simpler English and made it so that all of you could pretend like you were smart too when you read his books. To me, that's almost more of a powerful gift than being an engineer. The ability to explain things to people and be able to talk to people and not make them feel dumb or stupid is more powerful of a tool than really being an engineer. The ability to communicate and make others feel smart. That's a very, very powerful gift. Anyhow, like I was saying, he wrote this book called The Antenna Hand Guide. And on the Antenna Hand Guide, he explains SWR and its principles and operation of the station, and how with using coax, antennas and antenna matching networks really come into play. I was having a conversation with a gentleman the other night. He was telling me about his 400 ohm ladder line or open feed line that he was using, and how that actually is part of the antenna. Uh-oh. God, I love this stuff. You show me any other device in the world that would take this kind of punishment and not overheat, melt down, and launch its cookies. I'm not aware of one. The only thing I feel bad for in this whole box is this relay back here, because it's got all the watts going out plus all the watts coming back, and it's sitting there trying to hold the bridge, the contacts together. He discusses a lot of different theories in his books, and it is theory because we can model a lot of it. A lot of it you can do practical application, demonstration of knowledge or theory with the antennas. But he has a whole section that's about reflect and how it's not what we think it is, and it doesn't affect our components the way we think it does. Your output impedance on your output transformer and the output circuitry goes too high. The component sees that. It doesn't see the magical pixies coming back to the transistor. Another wives' tale that I want to dismiss with right now. Transistors have no shelf life. It's infinite. They last forever. 4CX tubes have a shelf life of about 15 years. The filaments start to corrode. The coating that's on the filament on 4CX tubes starts to flake off. So they have a shelf life. Now in operation, depending on how you go about using them, they have a shelf life of, in the amplifier, 3 months or 30 years, depending on how you, the operator, choose to operate it. But transistors don't go soft. They produce the same amount of power from day one until they die. The HFE gain is a little bit more complicated of a story. I could get into whole schmoo about that, how that's not actually what anybody thinks it is, at least on my side of the street, the CB side of the street. There's some very brilliant people that are on the ham radio side of the things that probably know, and there's a few people on the CB side of things that actually understand what that is. But as far as reflected power, it doesn't magically make it back into your transistors and cause the transistors to fail. The reason I want to bring this up is I'm really tired of dealing with this. This radio has caused more grief in the CB community than anybody will ever understand. This little SWR bridge here that's on the front of the radio. We've had them. They're in every Cobra 29. Hell, there's even one over here in this radio, right here. Okay? That's the reason there's a little button here that says SWR. I swear. It's flat. And we're transmitting into a dead short. Just saying. We've had them. They just weren't directly in front of your face, and you had to do other actions to get them to work properly. The bridge. This bridge has caused a lot of problems. I field probably 20 phone calls a week, if not more, of people calling asking about their coax links and how their input SWR is too high. Well, what's too high? Infinite dead short. I have to ask. I'm asking you guys, in your opinion, you're all going to utter out some number right now. What is too high? To me, 1.8 and below is fairly acceptable. You're not going to tear the radio up. You're not going to tear anything up. 1.5 is better. 1.2 is even better. 1-to-1, almost impossible in the real world to achieve, but according to this meter, everything must be 1.1. So I want to give a demonstration. When I say to people on the phone, when I say out loud, if your SWR is 2 bars on your striker meter, run it. It's not hurting anything. If you have finals that are popping in your radio, that might be because the gate voltage is too high, or there's not enough heatsink, or the quality of the components is so low that they can't handle a different aspect ratio other than flat. Just saying. There's food for thought. Just think about that. Maybe that bridge on the front of that radio isn't the end-all, beat-all knowledge. Maybe, just maybe, for a lot of years we told people, oh man, it's got an SWR bridge inside the radio, but you can't really trust that thing. It's not very accurate. Who's to say this thing is very accurate? I've had many builds where this reflect meter here, now please note, it's a $200 plus meter with a $130 element in the front of it. I would say that there's a little bit more accuracy and energy given to making that read correctly than it is over making this afterthought. Also can go in and change it by moving a potentiometer. This bridge, I would say that this is more accurate. I've had many situations where I've had less than 1/10 of a watt of reflect, and this thing is showing me that I've got a 3 SWR. How important is your SWR back to your radio? If you got below 1.5, run it. That's what I say. And you guys all need to relax. Take a seat in the back seat. I had another situation. I was down in California. I was sitting there talking with a guy. What was it? Saturday. No, Friday. Friday last week. And he was explaining to me that you can hear SWR in people's modulation. And I said, no, you can't. He goes, well, yeah, you can, because I can see it on the oscilloscope. And I asked him, well, how are you probing your modulation signal? And he goes, well, I'm probing it with a passive probe, and I'm looking at the RF going out to the antenna. I'm like, oh, okay, so what you're seeing is a signal distortion with the reflect being present in the feed line. And he's like, what are you talking about? The scope shows me my waveform and I can see distortion. No. He was confused. The difference between output carrier, induced modulation into that carrier versus your actual waveform that your radio is producing. Multiple different measuring points, but you can have pickup and pick up information from picking up the outward going RF, sure, and looking at it on a scope. But he was dead set that if your reflect got too high, it makes your audio sound distorted. That's not the case. When you hear somebody with distortion like that, that's because they're driving the shit out of one of their amplifiers. They've got a 100-watt radio going into a 1x4. So a 1x4 is designed to take like 30 watts, and you're putting 100 watts into it. Well, you've completely exhausted all the headroom in that driver transistor. Completely exhausted it. It's gone. So therefore you can have no signal growth, and that's when your modulation starts to get pinched off. I explained that to him. It was like a light bulb going clicking on for him. It was great. It was great to watch that. It was great to be involved in that conversation. Another thing I want to talk about is CBers, for the most part, run the cleanest amplifiers in the band. Oh, hold on. I just heard some amateur amplifier guys out there. They're ham dudes just lost their shit, right? Let me explain to you why. Why is it, do you think, that we can take 4 transistors in the final stage of one of our amplifiers and achieve 1,000 peak watts very cleanly out of those 4 transistors? Oh, it has nothing to do with saturation. No, it has absolutely nothing to do with oversaturation. No, it does not. It does not have anything to do with overvolting the component. It doesn't have anything to do at all how much drive we're putting into the part. We can take that exact same 4 transistors and put them into something that is broadbanded, designed to run from, let's say, 80 through 10 meters, to make the pallet that holds the transistors frequency response from 80 to 10 meters. The output potential of the device gets cut almost in half. It's the reason why in the amateur world we'll see 8 transistors do maybe 1,200 watts. The efficiency of the circuit for the frequency being put into it is not there. Let me continue. So then in the amateur world, because we have a pallet that's designed to receive any kind of noise you put into it, and we'll rectify it anywhere, we have to have a huge schmletny of frickin' filtering circuits that are on relays, and then we got to have a different matching network for it to be able to guarantee that the RF that's coming out of the pallet is not wide, it's narrow for that band. So you have a high and a low cut filter system. Most of the filtering networks only work on a high cut principle, or pardon me, low cut principle. So they cut everything out up to a certain frequency, everything above it can't go, and everything below can. Most CB amplifiers that are home built Remember, we're always in competition, going back to what we just talked about, always in competition to see who can get the most watts out of each part. How we achieve that is hyper tuning and mono frequencing, if mono banding, I guess would be the best way to put it. Certain people, they only talk on one frequency. They tune everything out for that one frequency, and they want to get every single little bastion of watt power on that one frequency that they can get. If you take that same amplifier that's tuned to run within that certain window of frequency and take it, let's say, from here over to here on the band, you're going to get a horrible response, and the amplifier won't work right. It just won't, because it is so hyper tuned for one frequency. Therefore, the internal circuitry naturally makes it so that the RF that is coming from this device cannot have a second and a third and a fourth order harmonic that is substantial enough to cause interference. That's the reason why I make that statement. I've heard most of my life in radio, well, you know, them CBeers and their splatterbox amplifiers. Well, there's some creds to that. Some guys on CB, they crank their modulation up too high, or they overdrive their amps too hard, or they whatever, and that can cause harmonic distortion. But as the general 6,000 foot in the air, eye in the sky looking down at the problem from way up here, the majority of folks don't work like that. It's a relatively clean band, right? The other thing I get really tired of hearing about is people constantly refer to the front end of their ICOM 7300 or their Yaesu whatever or their Kenwood whatever in the pan adapter, in which all that is another separate receiver that they scroll from the start frequency to the end frequency, and then it gives you a signal source that's independent from the receiver of the radio. Once you achieve an S9 to S10 signal in most amateur operation radios, you have a principle that takes place called oversaturation, where the receiver starts to get overloaded and it cannot notch out the specific frequency that you're on the pan adapter. And it starts to overload the pan adapter, and it shows it starts to get overloaded by a wider and wider and wider signal. Okay? I was at a ham meeting, some fellow amateur operators not too long ago, and the guy said, well, so-and-so and so-and-so, man, he runs a dirty radio and amplifier. I can see him from da-da-da-da-da-da-da. I sat there and I listened to it, and then I put my hand up and I said, pardon me, I don't know shit about Shinola, but how far are you away from this guy are you? He goes, oh, I'm about 2 miles. Oh, okay. So the guy that's 2 miles away running legal limit power, let me guess, your receiver's almost pinned in the corner. He goes, yeah. I can't hear nothing. It's because his incoming signal is overloading your receiver's ability to notch out all the other and get rid of it. I said, so what happens, just out of curiosity, I know that on your spectrum analyzer, which is, by the way, that's a spectrum analyzer. That is a pan adapter. This is another receiver that we trick people into thinking works like this. Two completely separate things. This is so, what happens when you reach up and hit the attenuator? He was running an ICOM 7300. Hit the attenuation button and put 18 dBs of attenuation on it. Well, the signal drops down to about 7 or 8. And I said, yeah, how much frequency is he occupying? And then he goes, well, only 5 kcs. I said, do you think that maybe it could have something to do with your proximity or the amount of signal that's coming into your receiver that's causing your pan adapter to show you this false presence of signal? Seven years have come and gone. I'm gray now. I didn't used to be. Gray now. Things are starting to hurt that didn't hurt 7 years ago. My friends coming, they're going. I'm losing more friends. That breaks me up on the inside. My friend Fred, I'm grateful that you were here to watch the birth of this. I know that you've gone on to another place. But I'm saying it out into the digital ether. I'm glad that you're here with me when I develop this. And I'm glad for all my other friends that have come along and let me be able to develop things for them too. There's more fun stuff coming. But still, for the life of me, I don't know why we don't have more people building these things. I just don't. 7 years later. Gentlemen, I thank you for watching. I will be on the road all of next month. So if you call me next month, I will not be able to supply you with the same services that I could if I was here in this particular space, but I think it's for the greater good. I appreciate every single one of you guys following along. If you're interested in anything that we're doing over here, please take a minute. Come join us on Patreon. It's the best way to show support. Shout out to Penta for all the beautiful tubes they've allowed us to get. Shout out to Siglent for the wonderful test equipment that they've allowed me to have. Shout out to Bird for letting me have such wonderful, wonderful test equipment here. And shout out to Coaxial Dynamics that allows us to have elements that we can trust on our unknown standard. On that note, gentlemen, I'm going to go. Things change, but then again, things stay the same. I appreciate every single one of you guys. I mean that from the bottom of my heart. I thank you for the support. I thank you for the comments. They help with the algorithm. I thank you for the thumbs up. That helps with the algorithm. If you're not subscribed, you might want to think about it, because we're always doing cool shit over here at the House of BBI, because I've got cool customers like you that want me to do cool shit for them. On that note, peace. Be well, respect each other, take care of each other. We're all in this hobby together.